Okay, I think I've found out what is my problem. So this is my Kubernetes cluster, and so I'm going to restart the Kubernetes cluster. And the reason I didn't, my BIGIP controller didn't get deployed because I forgot to set up the secret for BIGIP and the services account. So just make me remember next time when I do a live demo, I better run follow the script instead of run each step manually. So here it is. Like I started my Kubernetes cluster and it deployed the Flannel daemon set and added the BIGIP node as a fake load to the cluster and create a secret BIGIP login for the BIGIP controller. So I didn't do this step. I didn't do this step to create the cluster services account for the BIGIP controller, and that's the reason when I run on this, the cluster didn't deploy. So instead of manually start, I'm going to run this script, and so again we are here, right? So we already did it, explained those steps, and so let's start the cluster. Okay, so let's wait for it is fully start up. As you can see here, still no Flannel interface. Okay, now you can see my BIGIP controller is running. The Flannel is running. So I should have the Flannel interface ready. And right, so that's the Flannel interface. Show def Flannel.0. Okay, VXLAN ID 0. No learning attributes, and no learning attributes. So we have the bridge. Let's deploy BiGIP pod. Okay, and we have the container bridge, and we need to add the Flannel VXLAN interface to the bridge. Zero master CI 0. Okay, it's member now, and so now everything should be ready. Get pod namespaces. So we have a controller pod running, Flannel running, 2 BIGIP box, with the IP here. So let's go to the big IP. There's no ARP, right? So there's no ARP for pod. So this is my Kubernetes node. That's ARP for the node, right? Not for the pod. And we should have a FTP entry on the big IP for the node. So this is our node IP. So this is a FTP entry on the big IP. As you can see, is it a dynamic? It's not a dynamic. It's created by the cluster big IP controller. But this part we want to do works is that we want to see the pod ARP is automatically discovered by big IP through ARP request, ARP reply, and not static. And so maybe let's run TCP down on the same 0 bridge, right? And not port 443. Let's filter out some noisy packet. So we run the TCP down on the Kubernetes node on the container network bridge. So if there's the ARP request, ARP reply, we should see the packet here. And here we on the big IP, let's start pin the pod. Let's pin the pod. So what's the pod IP? So this is a BitBox pod IP. Let's pin it. So before we pin, let's make sure there is no ARP, right? No ARP for the pod. And so let's pin. Okay, ICMP, a request, get a reply, network works. And where is our, so this is the TCP down on the Kubernetes node. See the ARP request come in, asking for the pod IP, ARP address. So ARP reply from the pod, I'm at this address. And once the ARP works, the ICMP echo request come in, and the ICMP echo reply, right? So now if we check the ARP record on the big IP, we see the ARP record for the pod here created. The status is resolved. It has a 300 seconds timer by default. So, right? So we discovered the pod ARP through ARP request, ARP reply instead of create a static ARP. So when the controller created a ARP as a static record, here in the status it will show you the static instead of resolved. And let's look at our FTP. It also create a FTP entry for the pod. Like this is our pod MAC, right? So in the FTP entry, it also has a record like a pod MAC with endpoint to the node IP. And here dynamic, it says yes. And this record is created by the controller statically, so it says no, right? So again, And this is how I worked out this solution. And of course, there's some code reading, how to hack this, and how this learning works. And so yeah, there could be potential problem with this. And but I would like to know if anyone has an opinion about this. Yeah, so that's the demo. Thanks.